Welcome to today's Explainer. I'm thrilled to be guiding you through a really fascinating laboratory practical today. As a cognitive psychology professor, this is absolutely one of my favorite topics to teach. We are going to explore one of the most powerful and honestly kind of mind-blowing demonstrations of human cognition, implicit memory. Specifically, we're unpacking Memory Laboratory Experiment 5, focusing entirely on a phenomenon known as priming.
Okay, let's dive right into this and map out our journey. Today we're covering 1. The power of priming, 2. Types and mechanisms, 3. Setting up the experiment, 4. Procedure and results, 5. Real-world applications, and finally 6. Key takeaways.
Section 1. The power of priming. So before we get into the heavy data and the lab setup, I actually want to do a quick, interactive cognitive demonstration with you to show you exactly what we're dealing with here.
I want you to play along for a second. What is the very first word that comes to mind when you hear the word doctor? Just think about it. Did words like hospital, nurse, medicine, or maybe patient automatically pop into your head? Notice how you didn't have to consciously search your memory banks for those words at all. You didn't even have to work for them. They just appeared almost instantly, completely on their own.
Well, that rapid word association you just experienced, that is the absolute essence of priming. It's the phenomenon where our brain uses previously activated information to influence how quickly and accurately we perceive, recognize, and remember new information. It's really the ultimate proof that our memory is operating robustly in the background, even when we aren't consciously trying to remember a single thing.
Moving on to Section 2, Types and Theoretical Mechanisms. Now that you've literally felt it happen in your own brain, let's look at the specific psychological mechanisms that govern how these unconscious associations are actually formed.
There are a few key variations we need to know. First up is semantic priming. This happens when related concepts activate one another. For example, if you hear the word bird, your brain is immediately prepped to recognize the word sparrow, way faster than if you had just heard the word truck. Then we have repetition priming. This one is pretty straightforward. It just means that repeated exposure to the exact same stimulus improves your ability to identify it later on.
Now, let's build on that by contrasting two more types, perceptual versus conceptual priming. Perceptual priming improves recognition of things based entirely on their physical characteristics, what they look or sound like. Conceptual priming, on the other hand, is all about the deeper meaning of the stimulus. This contrast is absolutely vital because it highlights how our brains are constantly, simultaneously categorizing the world based on both superficial looks and deep underlying meaning.
So what's the biological engine driving all of this? It's a theory known as spreading activation. When you're exposed to one stimulus, like the word doctor, it temporarily activates a whole interconnected network of related memories. It is literally like dropping a pebble into a pond. The ripples spread outward, making all the associated information, like nurse or hospital, highly accessible. This spreading activation is precisely what gives us that faster recognition and vastly improved cognitive performance.
All right, Section 3, Setting up the Experiment. With the theory under our belts, let's detail the precise parameters of today's practical test so we can see this phenomenon in a highly controlled setting.
To properly isolate this unconscious processing, we have to strictly lay out our variables. Our independent variable here is the presentation of the priming stimuli right before the target. Our dependent variable, which is what we are actually measuring, is the accuracy and the response time of the participant. And to make sure our data is completely pure, we have to rigorously control things like the number of stimuli, the exact presentation duration, the time interval between the prime and the target, and of course, the testing environment itself.
To actually execute this test in our lab session, we need a specific set of physical materials. We're going to need our meticulously curated word lists and picture cards. We'll use a computer to flash the stimuli at exact millisecond intervals, alongside response sheets, a highly accurate stopwatch or digital timer to catch those reaction times, and a scoring sheet to track all the data.
Section 4, Procedure and Expected Results. Okay, we're now moving into the active phase of the laboratory experiment. This is the fun part, where academic theory meets observable, quantifiable data.
Here is our step-by-step procedure. First, we seat the participant and explain the task. But here is an absolutely crucial instruction. We have to hide the true purpose of the experiment from them. If they know we're testing priming, conscious thought interferes, and we really need pure implicit memory reactions. Next, we briefly present the prime words or images. Third, we immediately present the target stimuli and ask them to classify or respond to it. Finally, we meticulously record both their response time and their accuracy.
Before we reveal the actual results, I want you to predict the outcome based on that spreading activation theory we just talked about. What do you think happens to a participant's reaction time when they're shown a primed stimulus compared to a totally non-primed one? Take a guess. And boom! The data brilliantly illustrates the reality of our cognitive architecture. There is a stark, undeniable difference here. The non-primed stimuli result in a significantly longer reaction time, but those primed, semantically related stimuli, they result in a much shorter reaction time, alongside much higher accuracy. The brain was literally already waiting for the information.
So, the real question is, what does this all mean? Well, these findings definitively prove that our previous experience unconsciously influences our present cognitive processing. Because those memory representations were already activated in the brain, retrieval became faster and way more efficient. This experiment provides rock-solid empirical evidence for the automatic nature of cognitive processing and the sheer power of implicit memory.
Section 5. Real-world applications. Let's zoom out from our microenvironment for a second. While the data is super fascinating in a lab setting, the macro implications of this cognitive architecture are massive for our everyday lives.
First off, consider the educational impact. Priming is a foundational tool for learning. It improves vocabulary acquisition, reading comprehension, and concept formation. Expert teachers are constantly leveraging priming by activating prior knowledge before introducing new concepts to you. By doing this, they literally prime your neural networks, which drastically improves classroom comprehension and meaningful learning.
But the clinical and practical impact is equally profound. Priming paradigms are critical in neuropsychological assessments and studying language disorders. It's heavily used in dementia research and cognitive rehabilitation to help rebuild or even bypass damaged memory pathways. And on a practical level, it's the absolute bedrock of advertising psychology. Understanding how subtle cues in media unconsciously prime consumer behavior is a huge part of how our daily decision-making is influenced.
Section 6. Key takeaways. That brings us to the conclusion of our explainer. Let's do a final, structured review of the scientific findings we uncovered today. If you remember nothing else from today, take away these core lessons. 1. Priming influences your behavior entirely without conscious awareness. 2. Your previous experiences act as a catalyst, speeding up later perception and memory. 3. Semantic relationships, like our bird and sparrow example, measurably increase recognition speed. And finally, understanding priming helps explain learning, language, and everyday cognition, because it is the ultimate proof of implicit memory at work.
I want to leave you with this really powerful, provocative thought to take out of the laboratory and into the real world. Our brains are constantly influenced by information we are not even consciously aware of. The next time you make a snap decision, quickly recognize a face, or feel drawn to a specific product, I want you to ask yourself, was that a conscious choice, or was my brain simply primed? Thank you so much for joining me for this cognitive exploration today. Keep questioning how your mind works.